This build is complicated by the fact that there are some mains components. The biggest and beefiest of those is this 45 watt space heater to heat the inside of the box, obviously. The next is this LED lamp which I built. You can see a video about the build and also the LED testing here. That's not directly mains driven, it's driven between 18 and 36 volts in a constant current module, which this is, and it's got mains electricity coming in here and 18 to 36 volts going out here, so that's another mains component. And then there's the power supply for the unit itself. It's currently running from bench power supply. So there are some mains electricity stuff going in. And that's a concern for safety. So I'm thinking Tupperware or Tupperware, cheap Tupperware. I think what I'll do is mount the solid state relay to control the electric heater in here. I think there'll be a second solid state relay in here, and I'll also put the mains powered LED driver in here, and the mains power will come out of the top probably to go to the heater and the main power supply. The 36 volts will also come out the top at a different point, and the mains will come in at the bottom, and the whole unit will be attached firmly to the side of the box, probably here, using existing screws which are holding a shelf support inside, and then the cover will fit over that to keep it nice and safe. There'll be a flex grip on this side to keep that secure. I want a one mains plug solution for this thing, so it's got one plug, you plug it in and everything's ready to go. And that means I can't use these because I can't tap mains off of it. And if I want to use it, I've got to plug it into a second socket, so now you've got a two plug solution. So what I'm going to try and do is get into this one and see if I can safely decase it and then use it in some modular shrunken form to put in the case here, so that mains goes in, not via these pins, but by whatever these pins are connected to, and 12 volts comes out and exits the box and enters the electronics through a suitable regulator. Well, it's quite a bit easier than I expected. I noticed these tab type things, and whilst I couldn't press them in and withdraw the thing entirely gracefully, I could grind them off, and now the two halves of the thing will pull apart. So that all just hinges back. See that the mains pins are connected to an expected red and black wire. The earth pin is not connected and doesn't need to be for this appliance, and then we're straight into the board here. So I think we're in very good shape for reusing this power supply. It's 12 volt 1.5 amps, so it's quite beefy, so we're going to go with that. If you look at the back of this thing where the live and neutral pins are, they're anchored in here by some splayed copper terminals, and if you unsplay them, then what that gives you is a hole in the plug. So I can get the other one out, and I may actually be able to reassemble the whole thing and bring the exit wires out through here. We'll see. Okay, well, one of them's gone, which means that it'll stick like that, which is, I think, good enough for me. It's I'm very happy with the safety. So this is the thing with this sort of stuff, you can't really plan it because you don't know what you're going to find and what you've got available. And you can't find what you've got available until you find out what you need, so it sort of grows informally. I'm going to screw this through the back of the case into the shelf support. Of course there's a danger that the screw will do something dangerous inside the case, but the screw hole is here. This is the low voltage side of the adapter, and as you can see there's a huge amount of height here. So, and furthermore, the other side of the screw disappears into a piece of wood and doesn't emerge anywhere. So I'm very happy with the fact that this is a safe way of anchoring the case inside this case, and I'm also content with the fact that anchoring the case inside the case in this way is a way to increase safety. So now this hole here will align with that hole there. This case will be attached firmly. Actually, probably I'll move that over a bit, so I need a new hole, but that's no big deal. This will be attached firmly and will be a permanent fixture here, and I will insert this board once that's screwed in and route it from there. There's a minor ergonomic issue in putting a screw in there, and that's that you can't get a screwdriver in to tighten it up, so I've made a small access hole on the far side. I think it's a reasonable compromise. The case is still well worth having, and I can stick something over that if I want to. So this is the electronics box I've come up with. This is the mains enclosure. It's obviously a Tupperware, well, Tupperwoid, I suppose, cheap Tupperware substitute. It starts with the mains block, and that power comes up through this wire here. I tie knots in cables to stop them pulling out. If anyone knows of a reason why I shouldn't do that, I'm interested to hear. The only downside I can think of is inductance, which I think is negligible. Anyway, the live and neutral go into this connector strip. These two are live, these two are neutral, and they feed the rest of the equipment. This is a wall wart. The pins have come off. You saw me take this apart earlier, and the live goes into one of the lives and the neutral goes into one of the neutrals, so that's a no-brainer, and out comes 12 volts which feeds the electronics through that wire there, or will do. The earth goes into this earth cable where it meets with the heater, which is the only component with metal exposed to the outside world. These two solid state relays each take a feed from the positive, so one positive comes out, goes to here, the second positive goes to here. So that means that this and this are switched positive. These are the ones where the microcontroller will change these levels through putting signals here. One of them goes into this module here, which is the LED driver, and that will go through there to the LED, and the other one goes to the heater. So this module turns the heater on and off through a microcontroller signal here, and this one turns the LED on and off through a microcontroller signal here. I'll connect both of the positives together and directly to 12 volts, and I'll connect each of the negatives through a MOSFET to ground. So when the MOSFET turns on, it acts as a high side switch and allows current to pass through here, which turns this light on, the optical coupler, and turns the mains live wire on, and the signal goes to the relevant device, heater or LED. So that's that. I may stick some tape across here in case these might be touched, but really you've no business in this box when the power is on anyway, so that shouldn't really be a problem. I've put a signal across this and that light comes on. Similarly here, this light comes on. It's a concern, you know, it's mains power and it will be operating largely unattended, although certainly not until I've got a lot more confidence in it. But that's the process anyway, and we'll see how that goes. Well, I'm working up to plugging this thing in. Firstly, I've just got a 9-volt battery here, and I'm just applying, there's no mains applied to this. I'm just going to apply the control signal across there, and we should see this little light come on. And we do. So now I'm going to plug it in and do the same thing. And we'll see. Right, plugged in, nothing blew up. Now the LED is connected to this, it's inside the box, but we'll see it. Ah, look, the LED comes on. So we're now controlling a mains powered LED through a microcontroller level signal, and no sign of. Now I'll stop the video at this point to show you a problem which I didn't notice at the time, but you can see it on this video. When I disconnect the signal, you can see that the LEDs in the box continue to flicker dimly. What I found out later on was that the solid state relay which was controlling the dimmer was faulty, and even with the signal removed there'd be about 80 to 90 volts coming out of the relay, which is why the LED stayed on. So I just had to replace that relay. Any problems? Unplug the mains. Anyway, I'll leave it there for this video. I hope you've enjoyed it. It's a really good feeling to realise that you can control mains powered devices through a microprocessor. It opens up a whole world of possibilities. Of course there are safety issues which you need to watch, but I think we're okay on this one. Anyway, lots more to come when I hook this side of things up to the electronics and the thing comes alive. So hope I'll see you next time. If you enjoyed the video, do please like it and think about subscribing if you're interested. Thanks.